So last class we have discussed that in statistics, okay, so random variable plays an important role, and that random variable we have defined what is that mathematically. Random variable I can write R. So R is a mapping from X is sample space to a real number R. That means if I have two uh, coins and tossing of two coins, so tossing of two coin means two coin tossing, we can write here, we can write, so two coins are tossing. So in that case, what will be our sample space? X will be first is H, second is T, that can come, then TH also come, then H also come, then finally is TT. Okay, so you can write in your own order. Okay, okay, let me write here. So there are four possibles. Okay, four possibilities. So if I am concentrating on one head only, one head only, so means in two toss one head only will come. So in that case, what are the case? This case and this case. Okay, and only one head. Okay, that means this. So if I write one head is 1, real number is 1. So yeah, probability of x equal to 1, it will come. So this will be 2 out of 4. So 2 by 4 or 0.5. So 0.5 is the probability. So that we know in random variable what will happen. But using the random variable, you can find the mean and variance also, or expected value. So expected value or mean is defined like this. Already we have discussed. Means if x is the number of element or the element or variable value, then what will happen? The expectation of this x, okay, random variable will be summation of small x f of x, okay, where f of x is the probability distribution function and capital X is the random variable. Okay, similarly, if we have a continuous system, so in continuous system, in place of sigma we have to write some, in place of summation we have to write integration, and that is from minus infinity to infinity. So this is, you can say, some area under curve, and the curve is x f of x. Okay, so this is the thing. Now next is how to find the variance. So variance we will see. So already we have seen this problem also. So variance.
Sir, can you explain the problem once again?
Okay, we'll discuss. We'll discuss the problem. So first problem is this. Where is the problem? Questionnaire. A lot containing 7 components is sampled by a quality inspector. That lot contains 4 good components and 3 defective components. So for example, there is a food inspector. Okay, so there are total 7 items. Okay, the chef has prepared, and 4 is good and 3 is defective. Okay, 4 are good items, 3 are defective items. Now what we have to do, and what the inspector will do, a sample of 3 will be taken by the food inspector. Okay, now we have to see that, find the expected value of the number of good components in this sample. So out of 7 he is picking 3 items. So 3 item is the sample, 7 is the lot, 7 is the total population, you can say. From out of population, 3 he has taken, and we are investigating that what is the expected value of number of good components. So out of 3 which he is picking, out of 3, what is the expected value of the number of good component in that sample? Okay, so that we are going to see. So what to do, as 7 component consist of 4 good and 3 defective. So any sample may present, okay, what 2 good, 1 defective, or even 3 good also, or 1 good, 2 defective, or
Sir,
all
only
defective.
one case where all are defective, right? Like all the three are defective.
Yes, yes. So one case all are defective, and one case it will be all are good. Other cases are also there. So how to do that? That we are going to see. First, we have to find out that probability function. That probability, the value f of x. So f of x, how to choose? 4cx. Okay, 4 out of 4x. X is if you are taking that good. Okay, 4cx into 3c 3 minus x by 7c3. So this is a combination formula. So using that we can find. So if x is one good item, then you will get some value. If x is two good item, then you can find out x is 3, then you can find out the probability. So if x is 0, okay, all defective, 1 by 35 will get, you put here and solve, you will get these values. F of 1 will be 12 by 35, f of 2 will be 18 by 35, f of 3 will be 4 by 35. Now expectation, how to find? We have to multiply the x value with f of x, okay, and take all the summations, because up to 3 we are finding. So mu equal to expectation of x equal to 0 into f of 0, 0 into 1 by 3, 35, plus 1 into f of 1, 1 into 12 by 35, plus 2 into f of 2, that is 2 into 18 by 35, plus last term 3 into f of 3, that is 3 into 4 by 35. So altogether, if you solve this thing, or if you add these terms, finally you will get 12 by 7, and that is 1.7. So expectation or expected number of good number of uh, item or component will have 1.7. Okay, so you can say nearly it is 2. Okay, 1.7. But mathematically, when you are solving, you have to give your digital value. Okay, like this 1.7 or something. If persons or something is asked, then that time you can approximate. Now in continuous also we can find out like this. You see, let x be the random variable that denotes the life in hours of a certain electronic device, let it be bulb or something, with the probability density function. I told probability density function will come when you will discuss with continuous case. So continuous case density, and discrete case it is called mass function. Okay, now probability density function is given and it is asked find the expected life of the of this type of device. Okay, so that you have to see. Here in this probability density function, x is greater than 100, so that we have to see. That means from 100 to infinity, that we have to see. So that is that will give the expected life. So x into this function value dx, and integration from 100 to infinity. So whatever with the area under the curve, that will give you the number of hours life. Okay, so 200 I think hours, 200 hour will be the expected life of that electronic device. Okay, maybe you can say bulb or something. Now variance and covariance, okay, those things are there, but we will concentrate on variance. Covariance are not there. So when we have x, let x be a random variable, and f of x, that we know probability distribution, and we have mean mu. Okay, mu is given, then we have to find the variance, and the variance formula is what? Sigma square. Sigma square is expectation of, here This is important. There we have expectation of x. Now here we are finding expectation of capital X, means random variable x minus mu whole square. Okay, discrete case it is summation. Okay, continuous case it is integration. Simple. Okay, you can find it. And if you will take square root of this variance, it is called standard deviation. So these two quantity are very important when you have data. Then how it is important? Because how much your scattered data, whatever data is there, how much it is deviated from the mean. Okay, that will decide. This variance and standard deviation will be useful for that. Okay, so that's why it is important. If its value is less, then good. More, then you need to work out on your procedure, you need to work out on your systems to get better variance. Okay, the variance of a random variable x is this. You can write this sigma. Okay, this way also. For some case we'll see, different cases are there also, but the general formula is this, that you have to remember: expectation of x minus mu whole square. Okay, and if you have mean and variance, some properties are also there. Okay, like expectation of ax plus b, like linear combination is there. X is a random variable, a and b are constants, then you can write constant, you can take outside, that is a into expectation of x plus the constant b. Similarly, if you set a equal to 0 here, then what happens? It will be b. So expectation of b will be b, any constant value. That expectation of a constant value will be that constant. Okay, so if you set b equal to 0 here, then what happens? Ax will be remain, and what we will get? E of expectation of ax. So expectation of ax means constant will take outside, and this formula will become a into expectation of x. Okay,